In this video, we're going to start section 7.6.5 on the properties of variance and covariance. So we've already seen two properties of covariance in proposition 7.6.1, namely that the covariance of xy is the covariance of yx, and the covariance of xx is equal to the variance of x. So we're going to continue with the properties of covariance and variance in proposition 7.6.5. So for random variables x, y, z, and w, and real numbers a, b, c, and d. First we have that the covariance of ax plus b and cx plus d is equal to ac times the covariance of x, y. So the addition of constants doesn't change the covariance, and the multiplication of multiplicative constants can come out of the front. So let's do a proof of this. We're going to use the computational formula. So we know that the covariance of ax plus b and cy plus d can be written or calculated as the expected value of, well, the product of the two. So that means that we've got ax plus b times cy plus d, need parentheses around those, minus the expected value of each. So ax plus b times the expected value of b cy plus d, cy plus d. So now the rest of it is really just foiling out and using properties of the expected value. So we can FOIL inside the first bracket, and we are going to get the expected value of, and so we're going to have acxy plus adx plus bcy plus bd minus, and then here we're going to have properties of the expected value that I can write the first as a times e of x plus b, and this is times c times e of y plus d. Now, the first part can be, we can use the properties of the expected value again to split this up, and so we'll do that. We can split it up over the addition and subtraction and bring out the constant. So we get ac times the expected value of xy plus ad times the expected value of x plus bc times the expected value of y, and the expected value of a constant is a constant, minus, and then we will multiply through these two parentheses. So minus ac expected value of x times expected value of y. I'm going to need a little bit more room, so let's bring that over. And then, where are we here? Plus ad times the expected value of x plus bc times the expected value of y, and then plus bd. So we can see that a lot of these terms are identical. So since I have a minus here in front, this ad expected value of x will cancel with this, bc expected value of y will cancel with this, and bd will cancel with bd. So what do we have? Well, we've got ac e of xy minus ac e of x times e of y. So let's factor out the ac, and we're left with expected value of xy minus expected value of x times expected value of y, which is exactly ac times the covariance of x, y. That is the computational formula of the covariance. So that is exactly as required. Now we can apply that here. We can apply that on the variance in property 4, because we know that the variance is the covariance of a variable with itself. And so this will end up by giving us the variance of ax plus b will give us a squared times the variance of x. And so the proof of that is exactly as I just said. We're going to use the fact that the variance is the covariance of ax plus b with itself, ax plus b. And so the ax plus b, well, that's in the same spot as here, but ax plus b, the second one, is in the position of cx plus y, so we get AC, which is A times the covariance of xx. So we're going to have A times the covariance of x, and well, A times A is A squared, and the covariance of xx is the variance of x. So there are a couple more properties. We're going to split these up into 2 videos, so we'll come back in the next video and do properties 5, 6, 7, and then there's a nice theorem on the next page which also relates to these.